Hello folks, and welcome back to another Blue Monkey Forensics video. In this video, we are going to be looking at the Magnet Virtual Summit 2025 CTF answers for the Cipher questions. So one of the main things is I would highly recommend looking at this page from Kevin Pagano, because this is where you are going to be looking for all your tools. Specifically, this Cipher one, I'm thinking that I probably use half of these for this particular year's CTF. So let's get into it. Question 1, knock knock. And it only really gives us this file with these dots as the only clue. All right, so I have no clue what these dots mean, so I'm just going to go to the internet and figure it out. I typed in knock knock Cipher, and the first thing that comes back is something called tap code. And then it actually points to the Dcode page. So let's go ahead and jump to the Dcode page. And then I guess we can enter our dots. So it does explain what the tap cipher is. And in brief, it's basically each dot represents a tap on this grid, and they're paired up. So the first coordinate, for example, is 3. And so it's going to be 3 down. And then the second thing is 1, so it's 1 over, so it's the letter L in this particular 5x5 grid. And you can choose different letters to use in there, but I just started with the default, which, as you can see, only has 25 letters out of 26. So the letter K, it has been removed, right? But again, you can choose to do this how you want. I'm just starting with this as the default, and it seems to have worked pretty well for me. All right, so I'm going to go ahead and hit decrypt, and then it's going to tell us that the word actually becomes LOCCEDOUT, but I believe the missing letter K is sometimes substituted for the letter C. So I guess locked out or loosed out, either one seems to be the answer. Question 2, the Masked Singer. And so there's a link that goes to a folder which has a bunch of graphic files, and they all look like part of a jigsaw puzzle that, if you put together, is probably a QR code. This one took me forever to do because the puzzle pieces actually need to be rotated and put in the right orientation and so forth. But the thing to keep in mind is that the 3 main corners, right, of the QR code. So if you have those 3 anchors, then that's a good start. Then I got onto an online QR code scanner. So I scanned it from the image, and then once you scan the image, it comes up with a URL. And when I click on the URL, of course, I get rickrolled. I should have known it. Damn it! Gets me every year. Question number 3, capital offense. So we're basically given a file to decode the secret message. And so the first thing I'm going to do is take a look at the contents of the file with the file command, just so we know what it is, because there is no extension. And it comes back and just says data, so not very helpful. So next thing I do is usually do an XXD, so I'm going to look at the hex of the file. I'm going to pipe it through more. And I got a bunch of capital B's and then capital DNEI. That doesn't look like a header for anything I recognize. So I'm going to go ahead and take a look at the rest of the file all the way to the bottom. And here I see something that looks like paint.net backwards. And then here I see something that looks like textsoftware.paint.net. And then here I actually see PNG. So this looks like the header for a PNG file, which fits because it's also got the I header. And then the very first thing that we saw, NEI, is basically IN backwards. So this is the stuff for a PNG file. So I believe what we have here is just a byte reversed file. So let's go ahead and write some quick scripts here to reverse the entire file byte-wise. So I'm going to use XXD again with a -P for plain. All right, so this will basically only spit out the hexadecimal without the first column here, which is the byte offset. Is also going to skip the ASCII here on the 3rd column. And then I'm going to do -C1 which is going to spit out only one column of data. All right, so I'm going to read in the file of Cipher, and then I'm going to pipe that into the tail command with the -r option. So what this is going to do is basically read the entire file backwards and spit it back out, which is what we're trying to do. And then I'm going to pipe all of that back into XXD so that it goes back into a file. And again, I'm going to use the -p so it doesn't have first and third columns, right? Just in plain mode, and then the -r. And I'm going to redirect into a file called capital.png. Okay, this is actually pretty amazing that I made no typos this first time out. All right, so now that we have this file, I'm going to do open of capital.png, and out pops this PNG file, which to me looks like the state of Tennessee. If you don't live in the United States, this might be a challenge. Anyways, this is the state of Tennessee, and I do know that the capital of Tennessee is Nashville, which is right there in the middle of the state. So that is indeed the flag, Nashville. Question 4, pigs in a blanket. So again, we need to decode the secret message, and this time we get something called cipher.text. And so looking at it, it looks like a bunch of gobbledygook with a lot of ampersand in there. So it looks like every fourth character or so is an ampersand. So that might be something, but I'm not exactly sure what that is. So I actually did Google ciphers that uses ampersand, and nothing came up. So then I just basically said, all right, how about just pigs in a blanket cipher? And it comes back and gives us the Pigpen cipher translator. I copy and pasted our text in there, and it comes back with more gibberish. So this is not it. And then the next link goes to the Pigpen cipher in Dcode, and looks like it actually needs to use those particular symbols as the key. So that's definitely not it. And the next one down is just a bunch of images for pigs in a blanket. So all these pictures got me really hungry, but doesn't give me any good answers. So then I went into Dcode and tried to use the automatic cipher identifier. I pasted it in there, and it tells me that it's very strongly suggests it's the keyboard change cipher. And so if we look at that, there's a bunch of settings you can do, and I just put it on the automatic because I don't really know how to change it. And kind of looking down at all of these possibilities, nothing really fit. So I'm just going to go down the list, try the rote 47 cipher, decrypt that. That's also a bunch of gobbledygook, so that's not it. Next one down is the substitution cipher, and I don't really know, once again, what kind of substitution to do, because the code has ampersands and other punctuation marks, right? Not just alphabet. So I'm not quite sure what to do with that. So I moved on to the next one, which is ASCII 85. And I just left all the defaults, and I hit decrypt. I don't know what this is, but this looks like a pattern or something. So then I basically just copied this and then went back to Decode Cipher Decoder. And then it comes back and tells us that it's the bacon cipher with a strong indicator. And that makes sense, right? Pigs in a blanket and the bacon cipher. So I just basically just said decrypt. And the first thing that comes back is the words delicious, which I absolutely agree with. I love these little sausage things. Yeah, I'm not quite sure how the ASCII 85 comes into play, or what part of the clue tells us is ASCII 85. I just got this by blind luck. Question 5, dressing with a dot of 17 spices. All right, so the clue basically says decode the secret message, which is a WAV file. And if we listen to the WAV file, it sounds like Morse code. So then basically what I did was search for a Morse code decoder, and the one that comes back is basically the same one that is on Kevin Pagano's Start Me page. So I probably should have just started there, save me a little bit of time. All right, then I upload the file and then start playing the sequence. And as you can see, it basically comes back to a sequence of numbers, commas, and spaces. So clearly they are words of some sort, right? It looks like the numbers range up to 26-ish. So it seems like a pretty straightforward conversion from numbers into a alphabet letter. So basically I copied the code and pasted it into Decode Cipher identifier. And the first thing that comes back is the letter number code, or A1Z26. So once we click into there, there is a bunch of options that you can choose, especially the alphabet and the code for the space character. But I'm just going to go ahead and hit decrypt. And we get a bunch of options back here. And you can see they're all a little bit different depending on how you arrange the letters, right? So you can start with up top here, it says A is the number 26, and all the way down to Z is 01, and so forth. Or you can start with A equals 0, and wrapping around to A is also equal to 26. But I'm just going to take the one that basically maps A to the number 1, B to the number 2, etc. So it comes back with this particular string here. And at this point, instead of copying and pasting it back into the Cipher identifier, I noticed up here at the search bar, it says Caesar. And I go, oh, you know what? The clue is dressing, Caesar dressing. And actually, Caesar ciphers are very popular in the CTFs. So I'm just going to go straight to the Caesar cipher page and see if this works out. And then one thing that you can type in is the shift or key number. And since the number of spices in the clue is 17, I am going to put that in there. And what we get as a result is magnets are attractive. And don't forget that we could have actually put in the spaces there to make it actually read like normal. Question 6, 100x scale. And again, we have to decode the secret message, which in this time, it is a WAV file. So we play this WAV file. And it's just a bunch of clicks and stuff, and it's not Morse code. So maybe it's got something to do with the frequency. So I'm going to bring up the spectrogram of this particular sound file. And there are a bunch of different online tools that you can use. But I decided to just get some practice with FFmpeg. And so I'm going to go ahead and use FFmpeg. I'm going to use the show spectrum pick option. And what this is going to do is create a graphic file that is basically the spectrogram. So once I go ahead and run this program, I already generated this once, so let's go ahead and overwrite it. And when it's done, I'm going to go ahead and open it. And as you can see, there are very distinct frequencies and tones in this file. And it looks like there's 3 letters and then a space maybe, and then another 4 letters and then a space, and then 2 letters and a space, or 2 spaces maybe, and then a bunch of more letters and so forth. So to me, I'm already guessing that this says the flag is something. So now the question is, how do I convert this into letters? And so I'm pretty sure we got to get the frequencies, right? Get those distinct frequencies. And so what I did was I wrote a Python script to go ahead and run through this file and look for sampling points of every 0.2 seconds, look for the peak volume and then get the frequency of that particular volume. And this took me a while to write the program and test it out and make sure I had the right offsets and whatnot. But essentially, here's my program. And when I run it, I get these distinct frequencies. So actually, one of the other things I did was, because the frequencies itself doesn't really convert into anything, and the clue says 100x, so I decided to divide all the frequencies by 100 to get these numbers. And this actually seems to make sense, right? Because the space character in hex is 20, and then in decimal is 32. So there's a bunch of 32s that we can see here, which kind of coincides with my theory that those are basically just letters. So then I'm going to go ahead and copy all these and bring them into CyberChef. And once I'm in CyberChef, I'm going to use the from Decimo operator. One last thing I need to do is that I need to set the delimiter. I think the default is spaces, but I actually have line feed. So I'm going to go ahead and make it a line feed. And then you can see the output. The flag is Illuminati. Question 7, hidden spirits. Once again, we got to decode the secret message. In this case, it is a PNG file. And so once we take a look at the file, it's Matt Damon from the movie The Martian. I highly recommend this movie. It's fantastic. Anyhow, I spent hours and hours and hours trying to figure out if there's steganography contained in this. I looked at the hex. I was unable to find anything. So basically, I did not get this one. The answer comes from Andro6, who incidentally is the first person to finish the entire thing with the perfect score. So he did a pretty amazing job. And this is essentially the way he did it. So basically, if we go back and look at the Start Me page from Kevin Pagano, we see that there is a couple of links down to assist with this. The main one is image hidden text. Okay, so from this website, you can basically load a image and then just hit decrypt, and somehow it will find whatever hidden text is inside. And in this case, the hidden text is basically just vertical and horizontal lines. And I don't even know what this particular code is. But once again, if you go to Kevin Pagano's Start Me page, you will find another link. If you go to rumkin.com, they will talk about this DVD that was attached to the Mars rover. And rover was named Spirit, right? Hence the clue. And on the outer rim was a code. And I guess there is some methodology to doing this. And Rumkin basically was able to put it into a web page. And so he just popped it in there. And if you look in the bottom, after you say decrypt, it says, "Dare mighty things." So not in a million years would I have gotten this. This is incredibly hard. All right, so that's how I was able to solve the Cipher portion for the 2025 Magnet Virtual Summit CTF. If you like this video, I am sure you'll like these other CTF walkthrough videos. And make sure you hit the blue monkey to subscribe. Thanks, and happy hunting.